a static method inside that returns an iQueryable of t, and let's call it apply sort. Now this has to be our generic method, and it will be an extension method on an iQueryable of t instance. What else do we need to make this work? Well, we're going to need our sort parameter, which could be null. So let's predict support for that. Then we're going to need our sort mappings, which we are going to get using our sort mapping provider. And I'm also going to include an optional field that will represent my default order by, and this will only be used if the sort value is null or it's an empty string. And let's assume that by default, we want to sort based on the ID column, and you'll have the ability to change this for each query where you need sorting. So now I can say if string is null for whitespace sort, then I can just say return query order by, and in this case I want to specify the default order by, so I'll have to include the dynamic link namespace. So I'll say using system link dynamic core. Now if I go back to my query, I have to omit the nullable string argument, and then this should compile. What's the next thing we need to do? We need to extract the sort fields from the sort parameter that we are getting into this method. So we're going to split this value based on the comma, because it is a comma separated list, and then we're going to trim each value, and we are only going to select the ones where we aren't left with an empty string. And let's turn this into an array. So now I have a list of sort fields, but remember that this could be a complex value. It can contain the field name as well as the ascending or descending sort order. We are going to iterate over these fields and fill in a new list that I'm going to call the order by parts. It's just going to be a list of strings, and then I'll say sort fields and then for each. Let me drop in a small helper method called parse sort field that's going to take the sort field value, split it based on a white space, and this should give us the sort field and any sort direction if it exists. So I'm going to extract the sort field from the first element, and then we're going to check, for example, if the second value is the descending sort order, and in all of the examples we are doing case insensitive search. So then let's extract this into a tuple, which is going to be the sort field, and the is descending value, and we're going to get this by calling parse sort field. So let's pass it in, and I will have to fix the naming conflicts that I introduced here. So let's pass in the field into the parse sort field method, and we essentially get back the sort field value and whether we are sorting in descending order or not. Then I want to extract a sort mapping by accessing the mappings array, and I want to get the first value where the sort field is equal to the parsed sort field, and I want to use case insensitive comparison, and I'm using first on purpose because I want this to throw an exception if the sort field isn't valid. Then what about the direction of our sort? Well, I can define a switch expression on the is descending value and the sort mapping reversed order. And we have a couple of combinations that we have to cover. If we aren't sorting in descending order and we don't want to reverse this, then we are sorting in descending order. If we aren't sorting in descending order and we do want to reverse it, then we have to sort by descending. If we are sorting descending and we're not reversing it, then we return descending. And if we are sorting descending and we are also reversing this sort order, then we should return ascending order. If it doesn't make sense, take a second look and I think you'll be able to figure it out. Then I can finally add an order by value into my order by parts list. After I'm done with this, I can define my order by statement by doing a simple string join and join all of these values with a comma and specify my order by parts. And finally, I can return query order by and specify my order by statement. So this is my extension method. There is a decent amount of code inside, but there is nothing too complicated. Now let's go ahead and move all of these values into their own files. So let me move the sort mapping provider as well as the sort mapping definition and the isort mapping definition marker interface. And then let's close everything down except the sort mapping provider, the extension method for applying the sorting. I'll also close down the habit mappings, the program file, the habit query parameters, and let's put our attention back to the habits controller. We have to inject another service here, which is going to be our sort mapping provider, I can inject it on the controller level, or I can inject it just in the one endpoint where I need it, which is the getHabits endpoint. So let's inject it there, and let me grab the sort mapping provider. What this will allow me to do is to get the sort mappings using the sort mapping provider, where I can call the getMappings method, specify my habit DTO and the habit entity, and this should give me back an array of sort mappings. Then I can replace the order by statement that I have here with a call to apply sort. I can pass in the sort value from my query parameters, the sort mappings that I just extracted, and I will leave the default order by to use the ID column. And then let's start the application and test out the implementation that I created. I'll send a request to our get endpoint where I want to sort by the name in descending order, then I want to sort by the description, and finally the frequency type. If I send this request, we're going to land on our breakpoint, and first we're going to go into the sort mapping provider. Here you can see that I have just one sort mapping definition, which is provided to me through dependency injection, and it has a total of 12 mappings inside. We're going to return the mappings array, and then we want to go into the apply sort method. So I'll hit continue and land on the breakpoint that I placed here, and we're going to go over our first check because the sort value is not null or whitespace, and we're going to extract a list of the sort fields. So you can see we have name descending, description, and frequency type. So we're going to go over them one by one, parse the sort field value, and extract the specific mapping. And based on this, we're going to construct our order by parts. So let's skip over to after we're done with the for each loop. And you can see that the order by statement is properly constructed. We have name in descending order, description in ascending order, and then frequency type in ascending order. So I'm going to apply this to our current instance of the iQueryable, which is going to allow us to compose on this query, and we're going to execute this and return back a list of results. If I go ahead and change this from name descending into name ascending and send this request again, we're going to get back a slightly different set of results. If I omit this entirely, we should be sorting based on the ID column, which is the sort order that you see here. And if I navigate to my distributed traces, and let's take the second to last trace and observe the SQL query that I have here, you will see that we are sorting based on the name, description, and frequency type. In the query before that one, we were sorting based on the same columns, except the sort on the name column was in descending order, and in the last trace I have here, we are sorting by our default column, which is just the identifier of the habit. So we can conclude that our sorting is working as expected, but what would happen if I make a typo here? Let's say I specify an invalid sort field by making a typo, or even specifying something that doesn't exist at all. And if I send this request, we're going to get an exception inside of our queryable extensions. Our sort mapping won't exist, and we are calling the first method, assuming that such a value must exist. If I press continue, we'll get back a 500 internal server error, which is handled by our global exception handler. But this is actually a client mistake, and we should be handling this inside of our API. So let's see how we can improve on this. What we want to do is to validate the query sort property if it's not null. The simplest way how we can achieve this is by adding another method to the sort mapping provider. I'm going to drop in the implementation, and then we're going to discuss what we have inside. So I added a new method called validate mappings. It's also a generic method, and it accepts the sort parameter. If this value is null or whitespace, then I'm going to return true because this is a valid mapping. We won't be applying any sorting, so there's no need to return a client error. If it's not null or whitespace, then I'm going to split these values and extract the sort fields, but I'm only going to take the first value, which represents the field name. Then I'll get the concrete mappings for the source and the destination type, and I want to confirm that all of the sort fields that we have specified here exist inside of the sort mapping definitions that we have. So let's save this, and then how are we going to use this? Inside of our controller, we want to say if not sort mapping validator, validate mappings, and let's specify habit DTO and habit. I have to pass in the query sort argument, and if this isn't a valid mapping, then I can return a problem details response by returning a problem, setting the status code to 400 bad request, and I can provide an optional detail to help debugging, and I'll say that the provided sort parameter isn't valid. So let's go ahead and test this out. Let's send the same request again because it contains invalid sort fields. And if I send this request, I'll get back a 400 bad request this time. And the detail is going to say that the provided sort parameter isn't valid, and will also contain the sort query parameter that I passed in to the API. So this is how you can implement very flexible support for sorting inside your API, while also guarding against any client errors and invalid sort fields. And I think we can slowly wrap up this lesson about implementing support for sorting inside of our REST API. In the lesson before that, we also added searching and filtering, but one thing is still missing, and that is support for pagination, which we are going to cover in the next lesson.